Hello. In this video, we're going to be talking about the plasma membrane. So it's not wasting your time. Let's get right to it. All right, now when we're talking plasma membrane, I mean, one of the things we say right off the bat is that it's so important that it has its own chapter, not just its own video or own mention, but it's got its own chapter. So that's how important plasma membrane is. It's a super important organelle, and it's such a complex, efficient system, and the way that it operates, which is a major part of chapter 5, plasma membrane, and we'll certainly get into all of that. But to start off with, I mean, it's designed to be kind of that first check of recognition, allowing things into the cell that are needed, allowing things that need to be out of the cell to leave. But more importantly, if something doesn't need to be in there, doesn't want to be in there, or I should say shouldn't be in there, then it can be rejected. It is semi-permeable, meaning things can go in and out of it, and we'll look at some simulations to show the case that, but it can also say no. It can say hard pass, just like a but chapter 5, we'll talk all about that. It is constructed of phospholipids. We've talked about those in chapter 3, chapter 2. But those phospholipids with those polar heads and fatty acid tails, kind of got that charged, that interaction with water in various ways. It also has those proteins, those blue tubes that you can see, or the big blue circles. You can think of those as kind of pathways. But again, its main function is to control what comes in and out of the cell. So you can think about those medieval castles that have those big stone walls around them, or even in our own country in the cowboy and western days, we would call it, when you had those forts or cities with big fences around them and a main gate and someone there that says yes you can or no you cannot come in. You can also think of the security guard. Sorry about that. The security guard, like maybe a naval base or a military base that you show up at, and if your name is on the list, then you get to go in and you get the proper credentials. But if you do not have either, you do not get to go in. Okay, continuing with plasma membrane, as I mentioned, it's made of phospholipids. Those phospholipids are super important. They got that hydrophilic head that is polar, charged, so therefore it will interact with water. And they've got the fatty acid tails that are hydrophobic, and these are words that we went over strongly in chapter 3. Hydrophobic, it will not associate with water. That's the old vegetable oil and water thought process. And again, those proteins, those are gateways. When we look at chapter 5, we'll spend quite a bit of time talking about the various types of proteins and what they're associated with as far as what they work with to get into and out of the cell, whether it's an ion, a small molecule, large molecule, and the various ways that they do that. But one of the important things is that things have to be recognized, have to be understood what it is before it gains access to the cell. You've got the glycoproteins. As you can see, there's one in the upper left corner. Glycoproteins. Glyco obviously would be a reference to sugar, and you've got the proteins. They are important messengers. The glycolipids and the glycoproteins kind of work together to ensure the safety of the cell from foreign material. If something shows up, and the glycoproteins Their job is to double check it. Hey, is that us? Meaning, did we make that, or is that of the same DNA material that the rest of us are? If that's the case, then it's allowed to proceed. But if it recognizes, like when a bacteria cell shows up, and it's deemed not us, foreign material, the glycolipids be one to determine that, and the glycoproteins be one to alert the immune system that, hey, we've got a problem over here. We need help. You got the cholesterols. That's those little yellow things, kind of embedded. We hear a lot about cholesterol, high cholesterol, low cholesterol. And high cholesterol obviously is bad, but your body does make and use cholesterol in its proper setting, but it keeps the tails from tangling up, which would reduce the flow of materials in and out of the cell. One of the other things that plasma membrane helps with is homeostasis. Hopefully you're familiar with that word, but homeostasis is the idea of your body, your cells do things to try to maintain things in the manner that they should be, like your temperature, okay, like your pH level, like the amount of salts in your cells or water. It's a continual process. You can think about like the thermostat. You set the thermostat to a certain temperature. If you got the AC on, when it gets too warm, then the AC fires up. If you got the heat on, when it gets too cold, the thermostat fires to keep that in a certain range. And then your cells do that, and plasma membrane helps with that by allowing things in as they're needed. But when they're not needed, when we have too much, we shut her down. Okay, continuing our look at, boy, those are pretty small. But hopefully you can zoom in and see those. But one of the other things is the plasma membrane, the unique feature that it does in areas where absorption needs to occur, like in the intestines. Okay, you've got the inner lining of the intestines. Food is passing through. We want to absorb those. The plasma membrane can kind of roll up, as you can see, those little finger-like extensions. That's simply the plasma membrane in kind of an up and down fashion, kind of a folded accordion style. And when it does that, it creates lots of surface area. You can see the same kind of concept in the brain with the cristae and mitochondria with those folds. But when they have that unique design, those are called microvita, those little finger-like extensions. And again, that's just designed to create more surface area for the food to be absorbed. And of course, they're on the top half. It doesn't do any good to have it on the bottom half. But that's the idea of the unique feature of the plasma membrane. So that's our video over the plasma membrane. Hopefully you enjoyed that. And next time we get together, we'll be talking about the endoplasmic reticulum. So we'll see you then.